Welcome back to Max with RP. We have been discussing problems based on integration. Today we will continue to solve problems involving integration by substitution. So let us look at the first problem. We have integral of root of 1 minus root x by 1 plus root x dx. I equal to. So we want to integrate this function root of 1 minus root x by 1 plus root x dx. Suppose I put root x equal to sine theta. Then x is sine square theta. Then dx will be 2 sine theta cos theta. Now what will be I? I will be integral of root of 1 minus root x is sine theta. 1 minus sine theta divided by 1 plus sine theta 2 sine theta cos theta dt. I am substituting for dx as 2 sine theta cos theta. Now this is root of 1 minus sine theta. I am multiplying and dividing by the conjugate of the denominator within the root. So I will get 1 minus sine theta into 1 minus sine theta divided by 1 minus sine square theta. 2 I can take outside, giving you sine theta cos theta d theta. So I will be 2 into integral of 1 minus sine theta the whole square. If I take root, I will get 1 minus sine theta by cos theta. Square root of cos square theta will give me cos theta into sine theta cos theta. So this will be integral of 2 times sine theta minus 2 times sine square theta d theta. Now this will be minus 2 cos theta minus 2 into sine square theta. How will you integrate? I will write it as 1 minus cos 2 theta by 2 times theta. Continued. Okay. What will I get? This is minus 2 cos theta minus 2 into half will give you minus theta. Are you able to follow? Because 2 and 2 gets cancelled, integral of d theta. Then again 2 and 2 gets cancelled, integral of cos 2 theta is sine 2 theta by 2 plus c. But what is theta? If root x is sine theta, theta is sine inverse root x. So this is minus 2 cos of sine inverse root x minus sine inverse root x plus sine times 2 sine inverse root x by 2 plus c. So what I have done here is multiply and divide by conjugate. Finally it reduces to integral of sine theta, 2 times integral of sine theta, which is minus 2 cos theta minus 2 integral of sine square theta. Sine square theta you can write as 1 minus cos 2 theta by 2. So that 2 gets cancelled. So you will get integral of theta plus integral of cos 2 theta, which is sine 2 theta by 2 plus c. Substitute back for theta. Is it clear? Now, this is a very simple sum. Integral of 1 by x plus root x dx. So, what I am going to do is, I am going to rewrite this as, if I take out root x outside, I will get into root x plus 1 dx. Now, let root x plus 1 be equal to t. What is the derivative of root x? Root x, you know, is x power half. Derivative will be half x power minus half. 1 by 2 root x. Right? So, 1 by 2 root x dx equal to dt. Derivative of 1 is 0. So, dx will be 2 root x into dt. So, when I substitute here, integral of, okay, I am going to multiply and divide by 2, okay. So, I will get 2 dx. Now, 1 by 2 root x dx. Dx by 2 root x will be dt by root x plus 1 is t. Okay, this will become, so this 2 I am taking outside. So, this 1 by, this 2 I am bringing inside. So, 1 by 2 root x dx will be dt. Okay, I have used this. So, 1 by this 2 bring it inside. Okay, if you want, I will write it inside. So, dx by 2 root x will be dt. Okay, then I will be left with 2 times integral of dt by t, which is 2 log mod t plus c, which is 2 log mod root x plus 1 plus c. I hope you are all able to follow. It's a very simple problem. So, by this substitution works. Let's look at this problem. Integral of root of 1 plus x square dx by x power 4. Now, this I can be rewritten as integral of, I can write the numerator as root of x square into 1 by x square plus 1 divided by x power 4 dx. Now, this is equal to integral of root of 1 by x square plus 1. Root of x square is x. X by x power 4 will give me x cube dx. Now, let 1 by x square plus 1 be equal to t. So, if I differentiate this, what will I get? Look at the derivative of x power minus 2. Minus 2 x power minus 3. So, if I differentiate this, I will get minus 2 by x cube dx equal to dt. I don't have that minus 2, but I have this x cube here in the denominator. So, I am going to multiply and divide by minus 2. So, I will be reduced to integral of minus 2 by x cube dx will become dt. Root of 1 plus 1 by x square will be root t. And I have used this minus 2 and I have used this x cube. So, this minus 1 by 2 is remaining. 1 by minus 2. If I integrate t power half minus 1 by half, integral of t power half dt will be minus half into t power half plus 1, which is 3 by 2 into 2 by 3 plus c, which is minus 1 by 3. What is t? 1 by x square plus 1 to the power 3 by 2 plus c. T power half, if I integrate, I will get t power half plus 1 by half plus 1, which is 3 by 2 by 3 by 2. When I bring the 3 by 2 to the numerator, I get 2 by 3, 2 gets cancelled. Substitute back for t as 1 by x square plus 1. Is it clear? Now look at this problem. Integral of x power 4 minus x to the power 1 by 4 by x power 5 dx. Okay. I'm going to divide by x power 4 within the bracket, or rather take out x power 4. So I will get x power 4 into 1 minus x by x power 4 will give me 1 by x cube. See, I am dividing by x power 4. If I take out x power 4, this will become 1. And this becomes my x by x power 4, 1 by x cube to the power 1 by 4 by x power 5 dx. Okay, now x power 4 raised to the power 1 by 4 is x. So if it so the denominator will become 1 minus 1 by x cube by x power 4 dx. Why is this? Because x power 4 to the power 1 by 4 is x. X gets cancelled off with x by 5. So denominator becomes x power 4. Numerator, you are left with 1 minus 1 by x cube raised to the power 1 by 4. Okay, now I am going to make a suitable substitution. Let 1 minus 1 by x cube be equal to t. Then you will get minus x to the power minus 3 is t. Right? Derivative of 1 is 0. So this will be minus x to the power minus 3. So when I differentiate, what will I get? 3 times x to the power minus 4 dx equal to dt. 3 by x power 4 dx equal to dt. One minus 1 by x cube is t. 1 minus x to the power minus 3 is t. Derivative of 1 is 0. Differentiating, minus into minus 3 is 3. X to the power minus 4 dx is dt. That is 3 by x power 4 dx is dt. I have 1 by x power 4, but I want 3 by x power 4. So multiply and divide by 3 power. Multiply the numerator and denominator by 3. So I becomes equal to, now this 3 and this x power 4 dx will give you dt. Then you have t power 1 by 4, right? And then we have used which 3? 3 in the numerator and x power 4 in the denominator. So this 3 is remaining. So 1 by 3. So the final answer is I equal to 1 by 3 integral of t power 1 by 4 dt, which is 1 by 3 t power 1 by 4 plus 1 by 1 by 4 plus 1, which is 1 by 3 t power 5 by 4 into 4 by 5 plus c, which is 4 by 15. What is t? 1 minus 1 by x cube to the power 5 by 4 plus c. Is it clear? I have just integrated t power 1 by 4 is t power 1 by 4 plus 1 by 1 by 4 plus 1, which is 5 by 4. 5 by 4 taken to the numerator becomes 4 by 5. So the constant coefficient is 4 by 15 into t power 5 by 4. T is 1 minus 1 by x cube to the power 5 by 4 plus the constant of integration c. Is it clear? Next problem, integral of root of tan x dx by sin x cos x. Since I have root tan x here, I am going to write this as root tan x dx, and this sin x I am going to divide and multiply by cos x. Already one cos x is there, so this becomes cos square x. So I is equal to integral of root tan x by 1 by cos square x is secant square x. Root tan x by tan x will give you root tan x in the denominator. This is dt by root t. Let tan x be t. Secant square x dx equal to dt. Okay, so this will be 1 by root t if you integrate, that is t power minus half. If you integrate, what will you get? T power minus half plus 1 by minus half plus 1. So this is root t by half, so 2 root t. 2 root t plus c, which is 2 times root of t is what? Tan x plus c. So 2 root tan x plus c. Now look at the following problem. 1 by x into root of x power 4 minus 1 dx. Okay. If I take x power 4 minus 1 as t or t square, then 4x cube dx will be 2t dt, or 2x cube dx equal to t dt. So I will be equal to, now I want 2x cube, so I am going to multiply and divide by 2x cube. 2x cube dx, so this will become 2x power 4, x cube into x is x power 4 into root of x power 4 minus 1. So I will be equal to integral of 2x cube dx is t dt divided by, okay, 2x power 4, I will take that 2 outside, x power 4 will be t square plus 1 into root of x power 4 minus 1 will be root of t square, which is t. So this t gets cancelled, giving you dt by t square plus 1. Are you able to follow? I have written x power 4 minus 1 as t square. If I differentiate, what will I get? 4x cube dx is 2t dt, or 2x cube dx is t dt. Now substitute for 2x cube dx is t dt. This 2 I have written there. Then the denominator x power 4 is t square plus 1 into root of x power 4 minus 1, which is root of t square, which is t. So t gets cancelled. This is half into tan inverse t plus c, because derivative of tan inverse t is 1 by 1 plus t square. This is 1 by 2 into tan inverse t is root of x power 4 minus 1 plus c. Is it clear? So today we saw a set of problems where a particular kind of substitution that you choose helps you to reduce it in a form that you can recognize. Like the numerator is the derivative of whatever is given in the denominator. So derivative of the numerator, if it exists, derivative of the denominator, if it exists in the numerator, it becomes very, very easy to resolve such a problem. So until we meet next time, it's goodbye. I hope you enjoyed the video. Please share it with your friends. Thank you.